Hello guys, and welcome to my channel. Now in this video we want to solve the following exponential equations. Okay, so the number 1, 2 and 3, but in this particular video we'll only concentrate on the number 1. In subsequent videos we will do the second one and the third one. All right. Okay, now to look at this first one, we will need to rewrite this in a certain form that will help us to solve for the value of x. Normally, when we have this kind of equations, sometimes we make use of the logarithms. We just apply logarithms of both sides to a certain base that will help us. And some other times we reduce it to either a quadratic equation or a cubic equation, depending on how it is. So in this particular one, if you just observe the pattern, we have a base 2 here. We have a base 2 here. This is 2x, all right? Now, this here can be rewritten in another form. I can write this as 2 to the power of x, and I raise that to power 2. Okay. The reason is that I have seen here that this can be written as a quadratic expression on the left-hand side. Okay. This is how we will manipulate it, which I've just started here, to have a quadratic expression on the left-hand side, where we can have a term here to power 2, all right? The other term here just to a single power, and this is just a constant term, and we equate it to 0. Okay, so by the laws of indices, we see that when we multiply the exponent, that is 2 times x, we can rewrite it as 2 to the power of x, then everything to power 2, where we just multiply the powers and we get back to this. Alright, so the second expression, the second term here, I can write it as 2 to the power of x, alright, and I multiply it with 2 to the power of 3. Okay, so by additional law of indices, we can just add the powers when the bases are the same and are being multiplied together. Alright, so we go ahead and add 15 to that. 15, we don't need to rewrite it in another form because it's just the constant term. Now, we will see that anyway. Here, this 2 to power 3 can be written as 8, alright? And in fact, if I can write it as 2 to power 3 times 2 to power x, it's the same thing. So there is a reason why I want to rewrite that. I want to rewrite that because I see, okay, so this is 2 to the power of 3, which is the same thing as 8 times 2 to the power of x. Okay, now, we see this is 2 to the power of x, and this is also 2 to the power of x. Let me rewrite that in another ink so that we use it. This is 2 to the power of x, and this is also 2 to the power of x. Okay. Now, this is 2 to the power of x, and it is being raised to power 2, and this is also 2 to the power of x, but not being raised to power 2. Now, you see, if this is a square, and this is just a single term, where the coefficient is negative 8, and this is just a constant term, 15, independent of 2 to the power x, in fact, we can view this as a quadratic expression on the left-hand side, okay? Now, this will actually be possible if we change this to that form. For example, here I say let 2 to the power of x be equal to t. Alright? If we have that, this means that the left-hand side we are going to have, in place of 2 to the power of x, we are going to put t. So I'll just put this down, t. In fact, let's make this in blue. Okay, so that will become t in place of 2 to the power of x, and we square that. Alright? Minus 8 times, in place of 2 to the power of x, we just put t. Okay. And then we add 15 to that, we can equate it to 0. So that is what you get. In place of 2 to the power of x, we just substitute t. So this right here is a quadratic equation, alright? No, we have to solve for the value of x that will satisfy this equation. So maybe after solving for t, we will now make a backward substitution and get back to the x variable. Okay, so we just put this down. This is very important to us right now. So let's continue solving this either by using factorization method or by using the formula method. Okay, so we put it down as t squared minus 8t plus 15 equals to 0. Well, if we take negative 5 and negative 3, no, we are seeking for two numbers, okay? Which one we multiply, we get this 15 here. That is, when we multiply, we get this 15 times the coefficient of t squared, which is 1. And when we add them together, we will get the coefficient of t, which is negative 8. So seek two numbers whose product will give you the product of this coefficient with this constant term. So 15 times 1 is 15. So which two numbers are we going to multiply to give us 15? When we add them, we have negative 8. The numbers are negative 5 and negative 3, right? So we just go ahead and use those numbers. This is how we will rewrite it. We write this as t squared minus 3t minus 5t, t squared, right? Okay, minus 3t minus 5t plus 15, this is equal to 0. So we write it in that manner. Okay, so with the sum of this will just give us negative 8 as we had initially. Okay, so from here we like to do some factoring. We take t out of this, we have t minus 3, and here we just take negative 5 out and we have t minus 3, right, and we equate that to 0. That is possible because when we see 5 and 15, which is common, it is 5, right? But let's take a negative out since the negative is in front already. So if you take negative 5 out, to get this back, you have negative 5, you need to multiply with t, that will be negative 5t. And to get back your positive 15, you need to put down negative 3 here, such that when you multiply this negative 5 times negative 3, you get positive 15. Okay, so when you have minus here and plus here, and you want to factor out the minus, endeavor to change the addition to subtraction, so that it will balance what you had initially. Okay, great. Now we see that this bracket and this bracket, the contents are the same, right? In fact, we need to factorize the bracket out, and we get the remaining. So that will become t minus 5 times t minus 3, this is equal to 0. Okay, great. Now the next thing we'll do is to observe that the product of two terms is giving you 0. Okay, at least one of the terms must be 0. That is, it is either t minus 5 is 0 or t minus 3 is 0. Now, you can't multiply two non-zero numbers to have 0. Okay, multiplying numbers together to have 0, one of them must be 0. So that's why we are actually equating that. Okay, the reason is this is an unknown, so we don't know it. Okay, it must contain something that will give us a 0 expression after all. Okay, great. So that is it. Here we can simply solve for the value of t. Here t is equal to 5 or t is just 3. Okay, well, we didn't start with t, okay? We actually started with something great. We didn't start with t, actually. We actually started with x. So since t is 5 and t is 3, okay, we need to get the main unknown, like we need to solve for the main thing, which is x, not t, okay? So we need to recall that 2 raised to the power of x is t, okay? So in place of t, we will write 2 to the power of x. Just like in place of 2 to the power of x, we wrote t. Okay, so in place of t, we would like to write 2 to the power of x, this is equal to 5, or 2 to the power of x, this is 3. Okay, to actually solve for x here, what we will do is to take the logarithm of 2 to on both sides. That is to say, we will rewrite this in a logarithmic form. That will be logarithm of 2 to the power of x to base 2. Okay, so this is an introduction, and we equate it to logarithm of 5 to base 2. I'm taking logarithm to base 2 of both sides because this is 2, okay? To actually get rid of it, we need to introduce log to base 2. This is it. This power, it will take it backwardly, and we'll write it as a constant multiple, as a multiple of the logarithm, okay? That will become logarithm of x times logarithm of 2 to base 2, that is x times 1. Log 2 to base 2 is 1, okay? So x here, the x here will come and be written here. So we'll clean it off from this position. Alright, so we now have x times log 2 to base 2 is 1. So x times 1 is x, and on the right hand side we have logarithm of 5 to base 2. That is the first value of x. And on this second one, you can guess this, right? We'll just take logarithm of 2 to both sides, and all in all, we're going to enter with x is logarithm of 3 to base 2. Reason being that from this log notation, okay, from this whole equation, we can just do something here. 2 raised to the power of x is 3, changing from logarithm to indices. Okay, so that is very nice, actually. So that is for the first question, right? So that's all the whole process. Maybe you can go ahead and test your result if you want to. Let's say you pick the value of t, which is 3. You plug this in here, that is 9. 9 minus 3 times 8, that is negative 24. So 9 minus 24, that's just going to be 15. Sorry, negative 15 plus 15, that's 0. In fact, it's not necessary we are. Okay. Alright, thanks for watching. Let's go over to the second question.